Okay, sorry about that interruption, and let's finish this one problem, then you can have a quick 2-minute break. So looking, if I have a leg area of 8100 and leg area of 8100, to find the hypotenuse area, what do I do with these two numbers? That's right, we add them. So adding them up, 8100 plus 8100, you get 16,200. So I know if I want to find this distance here, I need to take the square root of this value. So the square root of 16,200, and you can go ahead and do that in your calculator. Doing that in your calculator, you'd press the second button. Remember the blue button, the second, which acts as the shift button, so you can activate all those little buttons on top in the same little blue color. And then you would press the x squared button to activate the square root button. Then you'd put the number, and it gives you a parenthesis when it does. You'd put the number you want to take the square root of, so I would press in 16200. And you can close that parenthesis, or you can just press equals, or both. And you end up with this kind of long number. So I know that C is approximately 127.279, let's say. And what did the directions ask us to round to? They asked us to round to the nearest whole number. So what's the nearest whole number to 127.2? Is it 127 or 128? That's right, it's 127. Which I know the distance from home plate to second base is 90 radical 2, if I was going to write this in simplest radical form, feet, or about 127 feet. So about 127 feet. So if you were playing catcher in the baseball game and had to throw someone out at second who's stealing first, you'd throw 127 feet. 2-minute break. Please put 2 minutes on the timer and turn to page 36 so you're ready to go. 2-minute break. Please pause the video and we will get going on page 36 in 2 minutes. No phones. Okay, let's take a look at page 36. It's 6.2c lesson. It's the distance between 2 points. So the first thing I want you to do is looking at this graph is I want you to find the distance between AC and the distance between CB. Go ahead and do that now with your groups. When you're looking at the distance of AC, this is a vertical distance, so we can always take 6 minus 3, and that's how you got 3, exactly. And we can find the distance of CB. That's a horizontal distance, so change in x values, -2 to 5 on the number line, or you can count. You get 7. Very good. Now let's connect these to make a awesome right triangle. And what's the side that represents the hypotenuse? Is it AC? Is it CB? Or is it BA? BA, you say? Good. You can write it BA or AB. I'll write in alphabetical order AB. Don't forget your line over it because it's segment AB. Now I want you to estimate the distance of the hypotenuse. No calculators, no Pythagorean theorem. Just estimate. If this is 3 and this is 7, what do you think this is? Is it more than 7? Well, yeah, because it's the hypotenuse. It's the longest one. So I'm going to say it's about, go ahead, give me a number. So now I want you to think about how can you determine the actual distance? How can you determine the actual distance? Well, what type of shape did we make? We made a right triangle. Let's talk about that. Since we have a, what kind of triangle? Oh yeah, a right triangle. We can use the Pythagorean theorem, to solve for the missing side length. So let's do that. Make your right triangle. We have 3, 7, and we don't know. I'm going to show my work with the picture method. So I know that this area is 9. What's this area? 7 times 7? 49. So I know this is 49 plus 9, 58. So I know that the missing distance, C, is radical 58. You can go ahead and use your calculator to estimate that. Take a moment, go ahead. Don't forget to use the second button and then x squared to activate that radical. And you get about 7 point, 2 decimal places, 62. Nice, very good. Well, let's look at this a little more abstractly. If we get rid of those numbers and we just look at these with coordinates, x1, y1, and x2, y2, what's the coordinate of C? Well, which axis is this? This is the x-axis. So if I go down, has the same x value, so this has to be x2. And it has the same y value as B, y value on the y-axis, so that's y1. So the coordinates of point C are x2, y1. Now it asks you the distance of AC. Go ahead and trace AC on your paper or fill it in. Is this a vertical up and down or horizontal side to side? It's vertical. So should I take my change in x values or change in y values? Change in y values. So this is y2 minus y1. And BC, well, let's look at BC. Trace BC for me. Is that a horizontal distance or vertical distance? You're right, it's horizontal. So should I look at my x values or should I look at my y values? That's right, I should look at my x values. So this is going to be x2 minus x1. So we're going to now use the Pythagorean Theorem to find the distance of segment AB. So we're going to be finding this distance here, AB. Well, let's redraw our triangle. So we have our height of our triangle, y2 minus y1. We have our run of our triangle, x2 minus x1. Sorry, you can't see that very well. That's better. And then we have our hypotenuse length that we're interested in, which we're not quite sure what that is. But remember, the Pythagorean theorem says that a squared plus b squared equals c squared. So we have a squared and b squared should equal our c squared. y2 minus y1, oops, the 2 goes down there, sorry, squared plus x2 minus x1 quantity squared is equal to c squared. Well, I know I'm going to solve for c squared, so to get rid of the square root, I take the square, to get rid of the square, I take the square root of both sides. So c is equal to the square root of y2 minus y1 quantity squared plus x2 minus x1 quantity squared. And this is really cool because this will work for any 2 points if I want to find the distance between them. So instead of a c, let's make this a d for distance. Change in y squared plus change in x squared. Go ahead, turn the page. And we've seen this formula before. We've seen this formula before when we were getting ready for state testing. The distance d between any 2 points with the given coordinates is this. It's really similar to our slope formula, and it's derived from the Pythagorean theorem. So we're going to show our work and be doing a few practice problems. So I'm going to do A with you. So let's do A together. to write the equation, I'm going to write d equals, and notice what's really cool is because you're squaring, it doesn't matter what order you subtract the x's, and it doesn't matter what order you subtract the y's, and it doesn't matter if you put the x's first or the y's first because we're adding. If this was 2 and this was 3, 2 plus 3 is the same as 3 plus 2. So here I'm just going to say change in y's being squared plus change in x's being squared, because remember our change in is the difference in them. So here I'm going to circle my y's just so I don't confuse them. I can do 5 minus 9 or 9 minus 5. It doesn't matter. I like to do 9 minus 5. That's going to be squared plus, it doesn't matter if I do 6 minus 3 or 3 minus 6. I want to do 6 minus 3. Notice I can't undo the radical in the square because it's being added in between, not multiplied. Remember, adding does not allow you to do that. So 9 minus 5 is 4. So we have 4 squared plus 6 minus 3, which is 3 squared. Let's keep going with order of operations. Let's square these. 16 plus 9. 16 plus 9, that's 25, and radical 25 is 5. So these 2 points, 3, 5, and 6, 9, are 5 units away from each other on the coordinate plane. I'll do one more with you. I'll do 5 with you. So taking a look at 5, again, I'm going to write my formula. The distance between any 2 points is the square root of the change in y squared plus the change in x squared. So taking a look here, circle my y's just to make it easier. Do you want to do 5 minus minus 3 or negative 3 minus 5? It doesn't matter which one. I'm pretty partial to 5 minus minus 3 squared plus change in x. 0 minus 2 or 2 minus 0. It doesn't matter, you pick. I like 2 minus 0. Being squared. Let's continue our order of operations. 5 minus minus 3 becomes plus. So we have 8 squared plus 2. Take away nothing is 2. 2 being squared. We still have this square root with us. 8 squared is 64. 2 squared is 4. 64 plus 4 is 68. Okay, 68. Well, I can't think of a perfect square off the top of my head, so I'm going to make a factor tree. So let's see, radical 68. Please join me. 68. Well, 2 works and it's still even, so let's try 4. 4 goes into 6 once, remainder 2. So 4 goes into 28 7 times. And then 4 is 2 and 2. Oh, and 17's prime. So radical 68, I know that is 2 squared times 17. What can you pull out? A 2. What's left inside? 17. So our answer is 2 radical 17. Nice. Very, very good. I would like you to work on 4, 6, 7, and 8. 4, 6, 7, and 8. First, I'm going to have you do 4, though, and I'll check back in with you. Do 4. I'm going to give you 3 minutes to finish 4, and I'll check back in with you. So pause the video for 3 minutes, and then we'll get back started.